All right, let's remember we're going to be trying to use this Casio 115 ES Plus for a lot of these problems. It wants to know the domain. The domain is the x value. Notice the x value here is 0, and it's a closed circle, so it's going to be bracket 0, and it goes to the right to infinity. So the domain is going to be bracket 0, comma, infinity. People ask about the 1. That 1 would be the range. The range starts at the 1 value, the y value, and that 1 goes up to positive infinity if it were asking for the range. But it is not. It is only asking for the domain. Wants me to evaluate the piecewise, so I have to plug -4 into one of these. Notice -4 is less than -2. I know that -4 is smaller than -2, so I'm going to plug -4 into that. So 2 times -4 is -8. Taking a look over here, I'm going to plug -2 in. So notice they're both -2, but this has the line, and I know that -2 is less than or equal to -2. So I'm going to plug the -2 again into the top one. So that would be 2 times -2, and that will equal -4. F of 0. Now I have to reevaluate this. 0 is greater than -2. So I have a -2 here. And I have to realize that 0 is bigger than -2. 0 is bigger than -2. So I'm going to put the 0 in there. 0 minus 2, well, that's -2. Now, all the other ones I think are going to be bigger than -2. I notice 2 is bigger than -2, so I put a 2 into that equation. 2 minus 2 is 0. And 4 is also bigger than -2. 4 is larger than -2, so 4 minus 2 will give me 2. So those answers were supposed to actually go into the boxes, and I just couldn't fit them in there. Graphing. I don't like the way this is set up. It should actually be, the top graph is y equals -x minus 1. The bottom graph is y equals positive 2x minus 5. So if I were to graph those equations, this one starts at -1 and then goes down 1 over 1. So this graph is negative. And notice it's aiming to the left. So I'm technically going to have a graph coming in negative, and then it's going to have a closed circle on it, and it's going to end at the x value of 2. Then this graph is positive. This graph is positive, and that's going to have an open circle at 2, and that's going to be a positive 2x going away from that. So I have to see which one's negative coming in with the closed circle. So that one's positive coming up to it with the closed circle. So it cannot be choice A. So let's move along here and see what else we can use. The next one is positive going in also. Positive going into an open circle. It can't be choice B or A. Ooh, negative coming in with a closed circle. This one's a negative coming in with a closed circle as well. And now I have to determine if it's C or D. Negative coming in with a closed circle. Negative coming in with a closed circle. Notice this is an open circle. This is an open circle. But this slope is positive 2. So it has to be this one coming away from it. Choice C. That's a positive slope, positive 2x. So the slope is positive 2 over 1. This is a negative slope, negative 2 over 1. And this is a positive slope, positive 3 over 1. So it's going to go positive, coming in, negative, positive. So it should have that little alternating. So negative, positive, negative. It is not A. B is positive, positive, positive. It cannot be B. C is negative, negative, negative. It cannot be C. Positive, negative, positive. Choice D. Sometimes we use this note slope man. So it's a positive slope going up to the left, a negative slope going down to the right. And this is an undefined slope. That's why he gets a little U there. And this slope going straight across is 0. So positive slope goes up. Negative slope from left to right goes down. Let's take a look at this graph. A little closer. So I have a y equals -1, and it stops at 0. Not -1. The x value here is 0. And it starts up again at 0 and continues as y equals 1. So it's y equals 1, and this is y equals -1. This domain is going to be x is smaller than or equal to, because it's a closed circle, 0. So now I have to determine which one of these I'm going to use. Choice A or choice B. Notice the arrow pointing to the left, and notice it is a closed circle. So I have to choose A. And the x value where it starts to aim to the left is 0. Now, a real quick memory mnemonic is whatever that one is, you're going to drop down into that one as well. Now I need to figure out what this equation is, and this equation is y equals -1. This equation is y equals 1. And the f of x just means y equals 1 and y equals -1 and y equals 1. This is the domain where x is less than or equal to 0. And this one, it goes the other way, x is greater than 0. Notice you can't have a line underneath both of them. It wouldn't be a function. So now it wants me to determine the domain. Notice there's always an x value. X value at 0 down here, no x value, that makes it a function. And then x value is going all the way to the right. So there's always going to be an x value. Now notice it says interval notation, so that's going to be -infinity to positive infinity. The range, however, there's only 2 values, y values for the range. Remember, x comes first in the alphabet, so x represents the domain because D comes before R in the alphabet. Domain range. Domains are the x values, the range are the y values. Now the y values are only -1 and 1. So we put it in these braces, and you use a comma to separate our answers. So it's going to be -1 and 1. Now, let's try to imagine if I were to continue this graph. Would it go through 0? And the equation of that line would be y equals 1x, because the slope is up 1 over 1, up 1 over 1, 1x, plus 0, because it would eventually go through 0, 0. So we would rewrite that as y equals x. That's all we would rewrite that as. Notice this is a closed circle, and x is less than -2, less than or equal to -2. So I need the less than or equal to -2 there. I might as well drop the -2 down into that box. I need the less than or equal to the closed circle for the first one. And remember, this I can rewrite as just y equals x. Now I need the equation of this horizontal line, and that's the Hoy problem. It's a horizontal line. So it's going to be y equals whatever that number is, 2. So y equals 2. Y equals 2 when x is greater than -2. Now, we need to figure out the domain. The domain is going to be interval notation from negative infinity to positive infinity. This is a weird range. Notice the range comes from negative infinity forever and then stops. The y value stop here at y value negative 2. So this range, I'm going to rewrite. I'm going to make it a little bit larger. So I'm going to rewrite that range as negative infinity, creeping up from negative infinity on the left, and it stops at negative 2. And that negative 2, if we'll notice, is a closed circle. So I put a bracket on it. They already give me the union, and now the only y value after that is going to be 2. So I just put it in those braces. I want to graph y equals absolute value of 5x. Absolute value is a v. I begin at 0, 0, and then I'm going to go up 5 over 1. Up 5 over 1. And that's going to give me this very narrow graph. Go back, up 5 over 1, and that's a narrow absolute value function. 11x squared, well, that's going to be x squared, and remember we implement 1, 3, 5. However, in this case, there's an 11 out front, so instead of going up 1 over 1 from 0, 0, I'm going to go up 11 over 1. I'm going to go up 11 over 1 over there, and then I'm going to connect the dots. And it's going to be a very narrow, skinny graph, parabola, because it's x squared. 1/10 x squared, I have a little shortcut for this one. We don't have to get too technical. The vertex is 0, 0. So the vertex is 0, 0, just like on the last one, because we're supposed to do opposite same, but there's nothing grouped with it. So that vertex was 0, 0. Now this vertex is 0, 0. I go to 0, 0. Now you see the 10 underneath? I'm going to go right 10, up 10, and place my dot. Some people just count on the diagonal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going to be a parabola going through those 3 points. And I call it a fat bottom girl because it's got a really large fraction on the bottom, and that's going to give it this fat bottom look when you graph it, a really wide berth for the vertex graph. If you were to graph this, you would see where its axis is, where it's symmetric, and notice that it would have a vertex at 0, 2. So if I were to graph it, I would begin at 1, 2, and then I would implement 1, 3, 5. I would go up 1 over 1, up 1 over 1, and notice it's symmetric about the y-axis. So that's where its axis of symmetry is going to be. And not all of them, just one, the y-axis. It wants to know if it's even, odd, or neither. So this is an even exponent. This is an even exponent. Now, if we inspect this, this is an odd exponent. And because they're not all even and they're not all odd, it is going to be neither. It is going to be neither. Now, an odd equation would look like this. X cubed minus 12x plus 4. Notice, that's an x to the 1. I can't have the plus 4. It has to be an odd exponent. So that's odd, and that's 1. That's odd. So that would be an odd equation. Now, if they were all even, and then I had just plus 5. That's technically x to the 0. So that plus 5, even though that 5 is an odd number, the exponent next to it would be considered a 0, and that would be an even function. Just trying to go over all the possibilities. Graph the following. So the vertex for this is going to be 4, comma, and notice there's nothing outside the brackets, 0. So I just go right 4, and then I implement my 1, 3, 5. So from that point, I'm going to go up 1 over 1, up 1 over 1, up 3, 1, 2, 3 over 1, up 5 over 1, and draw the diagram as best I can. This has a negative reflection, and it goes left 2. It's a cube. So I'm going to go to negative 2, plot my dot, and the array of points that goes with a parabola are 1, 3, 5. This is going to be 1, 7, 19. Those are the coordinates that go with the parabola. So I'm supposed to go up 1 over 1, down 1 over 1, but then I notice that it's a negative out front. So I go left 2, 1, 2, because it's opposite, and then I'm supposed to go down 1 over 1, up 1 over 1, and now here's the trick. I have to get that 7th number in. So I go up 1, 2, 3, 4, 5, 6, 7 over 1, 1, 2, 3, 4, 5, 6, 7 over 1, and that's what my graph shall look like. Opposite, same. Vertical stretch of 4, so I'm going to implement 1, 3, 5, but in front of that, I put the 4. So I'm going to go to 2, negative 6, right 2, down 6, place my vertex. It's a positive 4, so I'm going to go up 4 over 1. I'm going to go up 1, 2, 3, 4 over 1, up 4 over 1. Then I have to go up 12 over 1. Let's see if I can do it. This would be 2 plus 10 over 1. I need that spot there, I'm sorry. I'm going to go up 10 over 1. And it's going to be a very narrow parabola, almost like a needle. I'm adding, so I need to plug negative 2 into both items. So I'm going to plug negative 2 in there. I'm going to plug negative 2 in here. That's going to give me negative 2 minus 3, so that value is going to be negative 5. And then I'm going to do negative 2 squared minus negative 2. That's going to give me 4 plus 2. That's 6. So here we go. Negative 2 minus 3 is negative 5, and then I have to add them. That would give me 1. Now I want to subtract them. I'm going to put negative 3 in. So the first one would be 4 times negative 3 squared plus 4. And then I would subtract 2, negative 2, parentheses, negative 3, close parentheses, plus 5. So let's see, this is going to be 9 times 4, 36, plus 4 is 40. And then minus, because I have to minus that. 40 minus, now I'm going to take that 2 and plug it in there. No, I'm sorry, negative 3 and plug it in there. And that's going to give me negative 6, positive 6, plus 5 is 11. So 40 minus 11 should be 9. I want to plug 9 into that. That's 81 minus 10. That's 71. I want to plug 9 into that. That's 16 minus 9. That's 7. So my answer is going to be 71 over 7. Let me see if that simplifies. It does not. I'm locked in. They want me to add them, so I'm going to add 5x minus 4x and x squared. So I'm just going to string it out 5x minus 4x plus x squared minus x plus 3, and I'm going to combine like terms. So 5x plus 1x squared, 5x squared plus 1x squared, well, that's going to equal 6x squared. And then I have to do negative 4x plus negative 5x. That's negative 5x. Negative 1x plus negative 1x. Negative 4x plus negative 1x is negative 5x. And then I have nothing to add to the 3, so I just add the 3. So that's going to give me a final answer of 6x squared minus 5x minus 3. Next question, you want me to subtract them? So I'm going to write down 5x squared minus 4x minus, and now I'm going to wrap the x squared minus x plus 3 because I have to distribute that negative. So that's going to give me 5x squared minus 4x minus x squared plus x minus 3. So 5x squared minus x squared is 4x squared, because 5x squared minus x squared is 4x squared. Now I have to do negative 4x plus 1x. So 1 minus 4x is negative 3x. And then minus 3 at the tail end. And that's that final answer. F times g, I want to FOIL that. So I'm going to make a Punnett square for f times g. Let me see. I'm going to make a 6 square Punnett. There are 2 items on the vertical, and there are 3 items on the horizontal. I think these are very convenient, and they organize the data well. So I'm going to take the 5x squared minus 4x and lay it on the side. And I'm going to take the x squared minus x plus 3. Now I'm going to FOIL them out. So 5x squared times x squared is 5x to the 4th. 5x squared times negative x is negative 5x cubed. Positive 15x squared, negative 4x cubed, positive 4x, negative 12x. And that's what I would write down for f times g in order. 5x to the 4th minus 9x cubed. I messed up. That should be a square there. Plus 19x squared minus 12x. Now they want me to do f over g. That's pretty straightforward. I just take f, the 5x squared minus 4x, and I place it over g, the x squared minus x. Actually, x squared minus x plus 3 on the bottom. So I just take that top, and I put it on top of that, because it's f over g. That's what you would type in. Let me bring it over here so we can see it. So I just take the f value, which is 5x squared minus 4x, and I would put it over the g value of x squared minus x plus 3. The domain for all of these is going to be negative infinity to infinity. It's going to be negative infinity to infinity for all of them. So you just type in Control V, or negative infinity to infinity, for multiplying, negative infinity to infinity, for dividing them. I need to look at the graph. Some people think they need to figure out what the equation is, but all you really need to do is look at the graph for this one. So let's see what it means. So they want me to do f plus g of 2. Well, f is this blue graph, and at x equals 2, its value is 4. So that's going to be 4 plus, well, let's see what the red graph is. That's g of x. See how the g's there? And the red graph value at x equals 2 is negative 1. So 4 plus negative 1, well, that equals 3. Let's see what happens when I want to do f minus g of negative 1. So I'm going to go to x value negative 1, nothing there, so I go to the graph, and that y value is 1. So that's going to be 1 minus something. And I go down to the x value, 1, 2, 3, negative 4. The x value is negative 4. So 1 minus negative 4, and that's going to equal 5. F times g of 0, so let's see what f of 0 is. F of 0 is 0, g of 0 is negative 3, but negative 3 times 4 is, negative 3 times 0 is 0. Now I want to do a fraction of negative 1, the blue one, negative 1 is 1, and that's going to go over when I plug in negative 1 there. At negative 1, it's 1, 2, 3, 4. It's negative 4. So that answer is going to be negative 1/4.